2, 3, funky.
Number one is asking if you scuff electrons from your feet while walking across a rug, are you negatively charged or positively charged? The answer would be positively charged because you would expect for your rug to have a greater affinity for electrons, and that basically means the affinity for electrons means how much they want the electrons, and if it's greater, then that means your rug is going to collect the electrons from your feet more than your feet would from the rug. So if your feet is losing electrons, then you're going to become positively charged, if that makes sense, because your feet is a neutral object that is now rubbing against the rug, and so it's going to lose electrons to it, so it's going to be left with more positive charges, if that makes sense. Another basic thing, like slash the same charges are going to repel one another, and unlike slash opposite charges are going to attract one another. What is Coulomb's law? So basically, I feel like most times if they're asking you for like a law that has a equation related with it, 9 out of 10 times the law is just going to be describing the equation. So if you know the equation, you should be good on that. So it says the relationship of the electric force, which is the Fe, is equal to, or that's not what it says, due to the charge and separation distance. That makes sense because the electric force due to the charge, which is the Q1 and Q2 that's on top, divided by the distance squared, which is the separation distance. And the next sentence just basically describes the proportions and the relationship between the force and the charges and the distance. And that's just the whole law basically. What does it mean that Coulomb's law is an inverse square law? So basically, if you think about it, you use the is it rule of wands? I don't remember. But anyways, if you were to replace the whole top, the K, Q1, Q2 by 1, it would be your force is proportional to 1 divided by distance squared. Basically, inverse square law means whatever your how do I explain it? I don't know how to explain it, but just know that you would have to square it and inverse it. So if they're asking you how your force would be affected and your distance was tripled or something, remember you would square it, so 3 squared, and then inverse it, so 1 over 9. That's really what that equation 1 over d squared is describing. If you have 2 charged particles and 1 charge doubles, the distance becomes 3 times greater between the charged particles. What is the effect on the electric force? So, they just pretty much put the little symbols for whatever they represent, so like distance with a D and Q with the charges and stuff, and then that's the force. I'm gonna explain it in my head because I don't really understand what she put. So if you have 2 charged particles and one of them doubles, and we're using the rule of wands here, so the top is going to be, let's say 2, and then your distance becomes 3 times greater like I just described. So it would be 1 over 9, and then if you multiply that by the 2 on the top, that would be 2 over 9. So your force would be affected by 2/9, which is what she put. Okay, sorry. But yeah, that's basically the equation that she put that I just explained. What is the conservation of change? I didn't really understand her answer too much because she said the charges can be created and destroyed, but I thought it could not. But the most important thing is that the net charge is going to remain the same. So whatever you start with is what you're gonna end with. Okay, like I was saying, okay. If so, like no matter what loses electrons or which one gains electrons, just remember that your net charge is going to be the same. So basically that's what you should know. What property makes a metal a good conductor? How free the electrons are to move, I guess. And rubber a good insulator? How not free electrons are to move, because insulators are basically, their electrons are more like tightly close or something. I'm not too sure, but the limited restriction on the electron makes it a good insulator. So like The more it's restricted, the better. And then the more the electrons are free to flow in a metal, I guess that makes it a better conductor. So yeah, that's how I think about that. What is SI unit charge? Coulomb. I don't know what that means. Next, define electric potential energy. This is one of those that, like, if you ask me a question about it, I can answer it, but I don't really know how to explain it. Like, it's weird. It's just, yeah. Okay, the energy due to the location of a charge in an electric field. Well, I guess that makes sense. And if you don't understand it too much, just look up pictures of it and like the little pluses on top and the minuses on the bottom. I feel like that helps. Yep. What happens to the electric potential energy for the like this? I can explain it really good. So the distance between two like charges increases. So you're putting distance between two like charges. Don't forget, like charges don't want to be next to each other. They want to repel. So if you're putting distance between things that already want to be apart, you're helping it. So the electric potential energy is going to go down because they already don't want to be next to each other. So it's going to take less effort for them to separate, which is why that goes down. So think of that as energy, which is what's in the name. Just think of it as energy. Okay, unlike charges, they want to be apart. If you're trying to separate them, they're going to put in more effort to be next to one another. So the energy they're going to put in to get back together is going to increase. Next one. Distance between two like charges decreases. Again, they don't want to be next to each other. If you decrease it, you're going to put in more energy to separate. That's why it goes up. Distance between two unlike charges, they want to be next to each other, and if you put in less distance between them, that's good. You're not going to need as much effort to come closer together because that's what they already want to do. So I hope that makes sense. A negatively charged object is going to attract on a neutral object. I guess that makes sense because I think that is it conduction?
It's induction.
Is it conduction? I think it's induction. I don't remember which one it is, but one of them, whenever you bring a charged object close to it, the
protons do not move. Protons do not move. Protons do not move. The positive charges and negative charges separate.
Would run away, and the positive protons would run towards the negatively charged object. So like, it would still be neutral in the object, but it's just going to separate. So like, the like charge, the one that wants to attract to the negative is going to run towards it, and the other one is going to run away from it. Like, it's going to try to get as far away as possible. And if you were to use a method called grounding, you could get rid of those negatively charged electrons, and then your objects will end up being positively charged. Like, I hope I'm not rambling, but like, yeah, that's that. It would attract it because, yeah, I hope that makes sense. Okay, charges are collected on the surface of the Van de Graaff generator. What happens to these charges when you touch the Van de Graaff while standing on the ground? Like I was saying, the process of grounding, they would go through you to the ground. Yeah, because if you were to touch it, I'm pretty sure it has charges in it, so it's gonna go through. Okay, so here's how the process works. Electrons, they don't act in a way that is mostly good for them, because you would think that they would want to just like chill and like not move from a position that's good for them, but they do what is better for everybody else. So it would want to move into a bigger media. I hope that's the right word. I'm gonna look really stupid, but they would want to move into something bigger that's able for them to separate as much as possible. So from them to move from that little generator to your body is great, and for them to move into the ground of the earth, that's even better. So they will go straight through to the ground, if that makes sense. Why does your hair stand up? Because the charges are going to spread out as far as possible. So like I was just trying to say, they would want to move into something bigger so they can spread out as much as possible. So which includes the ends of your hair, and they all repel because they're all going to be the same charges. You feel me? Okay. Explain each of the following. Charging by friction. Two objects slide against one another, transferring the easy to knock of valence electrons. Oh, that's actually dope, because the valence electrons are the ones that stay on the outside and they're easily able to be taken away and stuff like that. So that's actually really a good explanation for that. Charging by conduction, so you have to use contact again. Induction is the only one you don't have to use contact for. A charged object touches a neutral object, sharing some of its charge with the object it comes in contact with. Basically, what you need to know for conduction, they have to touch, and whatever charge is on the first one is most likely going to be the charge that's going to be on the second object. So if you touch it with a positively charged, if they ask you a question and the option is, does it turn into a positive charge or something, it probably will. I think they're going to be in the same charge.
So like I was saying about how connection ends up being the same charge. So if it's affected by positive charged objects, it's going to turn into positively charged objects as well. Here's a picture of it. It's a little bit blurry, so bear with me.
Little metal thing over here is positively charged, and if you were to bring it in contact, both of them in contact, the electrons are going to go towards the positively charged rod, and then it's going to be less positively charged, but then your little sphere is going to be positively charged. So they're going to end up with the same charge no matter what, I think. Yeah, most times it's always going to be the same charge, if not all the time. So that's what I was saying. This is no charges actually transfer. Yeah, this one the charges don't transfer because they never actually come in contact. But there is a way for you to kind of like get rid of the charges and stuff if you don't want it to be neutral. But yeah, you see how it's still neutral, but like the minuses over here and the pluses over here, because like are going to repel. I mean, like is going to attract. No. The negative and the positive, which are opposites, are going to attract, and the other one is going to repel it, and it's going to try to get as far away as possible from it. And if you were to use a grounding, you can end up having the sphere turn into a positively charged object. But that's enough rambling. Okay, what's an electroscope? A connecting sphere attached to metal leaves that can attract and repel. And also generate an object and transfers charge from a charge band. Due to friction that comes to a metal connect. I don't really know, but yep, those are the definitions, I guess. What particles make up atoms? Neutrons, protons, electrons. Remember, your protons and the neutrons are going to be locked up in the nucleus. I really hope that's where they're locked up, because I'm gonna look really stupid. And your electrons are the ones that are free to they're the ones that are free to move all around in the atom, I think. But yeah, that's what makes up an atom. Where is each particle in the atom found? Protons. Oh my god, look at me. Protons and neutrons in the nucleus, and electrons in the electron cloud surrounding the nucleus in very specific but especially ill-defined energy states. I think, is that the valence electrons? Like the little levels and stuff? I don't know, but that's the definition. What is the charge of each particle within the atom? Proton plus E, positive charge. Neutron is 0 because it's neutral. Electron is negative E, so a negative charge. What force holds the electrons close to the nucleus within an atom? I guess that's the electromagnetic force. Didn't know that, but yep, now I do. What force ultimately holds the nucleus of the atom together? A strong force. I mean, that does make sense because they're closely tied away in there. Because the proton and the neutrons are in the nucleus, and you don't see them running around like the electrons. Why is an atom neutral? The number of electrons are equal to the number of protons. That's pretty. And an object either becomes positively charged by losing electrons, or by transferring it over, or by gaining electrons and becoming negatively charged, but never protons. Protons stay away in the nucleus. Why is an object like a balloon neutral? Because it's made up of neutral atoms. So basically the same number of electrons and protons. And most of your daily objects are going to be neutrally charged, because again, you don't want to be getting shocked everywhere you go by negatively charged or positively charged, I guess. How does an object become charged? It loses or gains electrons. How does an object like a balloon become charged? Usually by friction. If you rub like, I don't know, a cloth on it, it's probably gonna gain. No, it's probably gonna lose its electrons because the cloth is probably gonna be more. It's probably gonna have a greater electron affinity. But friction, I guess, is gonna make it positively charged. Make sure to know how neutral object interact with charged object. They're gonna be attracted because again, yeah, the charged object is gonna attract the opposite, and then the other one that's still in the balloon is gonna run away as far as possible as it can. How does a positive object lose its charge? It gains electrons to become neutral again. In what ways are the electric and gravitational force similar? In what ways are they different? Use the following to compare and contrast these forces. The equations are very, very similar. Like they almost look identical. I don't know. I guess I'll just go through a few. Gravitational forces are always only going to be attractive. Gravity cannot repulse anything, but electrostatic force can attract or repulse, as we have seen with like charges and unlike charges. Both of them are non-contact forces. Both equations have an inverse square relationship between the force and separation distance, because again the equations are very, very similar. Coulomb's law is significantly greater, and yes, that's it. I guess you just have to read through that and know that. Okay, so the top one is gravitational force. Again, it has the masses m1 and m2, and the distance again should be measured directly from the center of the mass or the charge and directly to the other one, like it's shown right now. Electrostatic force, again, that's the Q1 and the Q2. They could either be the same charge, so that positive charge right there could be replaced with negatives, and it could also be the opposite. So that's why it can be repulsive or attractive. This can only be attractive. So there's that. Very much a lot of similarities between them. There's another diagram. This is gravitational because you can see the M1 and M2. This is the charges with the Q's and stuff. I don't know why it's an R, but that is the distance between them. You can see how these are going in together because they are opposites, and these are positives, so they're going away from each other, and this is just going straight in because they are attractive. We have to describe blah blah blah. Electrostatic. Electrostatic should have larger vectors because it is a larger force. Only the electrostatic force can be drawn as a repulsive force. So yep, that's basically what I just went over. And yes, I lied. I'm gonna just go over the equations because yes. Okay, so you guys, in the first question I just read over it, and I just hope nobody gets confused really, but you guys see how the question is asking what the electric force would be, and they threw in the masses of the objects of the two spheres just to throw people off. Like there was no reason to tell them what the mass was if they weren't solving for gravitational force. So that was kind of and you guys notice how they didn't tell you that any of the charges are negative. So your final answer ended up being positive, so that means you're going to be repulsive, and if it ended up being negative, that means it would be attractive. That's something important to know. An electron and a proton that's the distance between them. Again, don't forget to square your distance on the bottom. Between the galaxies, what is the gravitational force and electric force? So this one is asking you for both of them. And when you solve for both of them, 9.72 times 10 to the negative 78. Also quite small, but much greater than the force of gravity. Oh, that's cool. And obviously you guys can see the negative that is on the electrostatic force, and that means they're going to be attractive. And so both of them are actually attractive because gravitational force can only be attractive, and this is attractive because of the negative. And so I guess you divide them. I guess you would divide because I think electric force is always going to be greater So I don't know if this question necessarily was necessary, but the answer ended up being electric force, and it actually told you how much greater it is than gravitational force for this problem. So yep, that's it. That's the end of the video, and this time for real. Okay, bye.